everyone. The headline of our lesson for today is First Derivative Test, Chapter 4, Lesson 4.1. Definition. If the function f of x is defined at the point x equals c and f prime of c equals 0, or f prime of c is undefined, then x equals c is called a critical value of f. We have three graphs. The first graph, the function f prime of c is 0 because the function is decreasing. Then at c, the function start increasing. Therefore, the derivative of the function intersect with x-axis at c. Therefore, f prime of c equals 0 and c is a critical point. For the second graph, at c, the graph has a sharp vertex, then the function is undefined and therefore c is critical point. At the third graph, the function has two critical points at c1 and c2 because the function is increasing, then start decreasing at c1. Therefore, the graph of its derivative intersect with x-axis at c1, and also the function is decreasing and start increasing at c2. Therefore, the graph of the derivative of this function intersect with x-axis at c2, and c1 and c1, c2 are critical point of this function. How to find the critical points? 4 steps. The first step, find f prime of x. Second step, solve f prime of x equals 0 for x. Third step, find y coordinate of the critical point. And the last step, check if f prime of x is undefined at any point c in the domain of f, then x equals c is also critical point. Note, if f of x equal x minus c to the power a over b, where a not equal to b, then x equals c is a critical value of this function. Steps of finding critical point for trigonometric function. The first step, find f prime of x. Second step, solve f prime of x equals 0 for x. Third step, determine which quadrant the angle lies in. If the function is in the first quarter, then the angle is the same without any change. If the angle is in the second quarter, then x equal pi minus the value of the angle. If the angle is in the third quarter, then x equal to the pi plus the value of the angle. If the angle is in the fourth quarter, then x equal 2 pi minus the value of the angle. As you know, in the xy plane, there is 4 quarters. In the first quarter, sine is positive. It is y-axis here, and cosine is x-axis, also is positive. Positive over positive, then tan is positive, since tan is sine over cosine. In the second quarter, the sine is also positive, but the cosine is negative, and positive over negative is negative, then tan is negative. In the third quarter, the sine is negative, and cosine is also negative, then tan is positive. Negative over negative is positive. In the fourth quarter, the sine is negative, and the cosine is positive. Negative over positive is negative, then tan is negative. Note, sine x equals 0, then x equals sine inverse of 0 equal to pi in the interval 0 to pi. This is the value of pi. Sine x equal 1, this is the value of 1. Then x equals sine inverse of 1 equal to pi over 2 in the interval 0 to pi. Sine x equal negative 1. This is negative 1. Then x equals sine inverse of negative 1 equals 3 pi over 2. cosine x equals 0. This is the graph of cosine. This is the value of cosine x equals 0, pi over 2, 3 pi over 2. In the interval 0 to pi. Cosine x equals 1. This is 1. Then x equal cosine inverse 1 equal 0 and 2 pi in the closed interval 0 to pi. 0 and 2 pi, but in the closed interval 0 to pi. Cosine x equal negative 1. This is negative 1. Then x equal cosine inverse negative 1 equal 2 pi in open interval 0 to pi. Note, if f of x is differentiable function, then if f prime of x greater than 0 on the interval I, then f of x is an increasing function on interval I. If f prime of x is less than 0, negative value on the interval I, then f of x is a decreasing function on the interval I. If f prime of x equals 0 on the interval I, then f of x is a constant on this interval. Note, to find the interval of increasing and decreasing for f of x, follow these 3 steps. Step 1, find critical points. Step 2, find the value of f prime of x where f prime of x less than c, c less than f prime of x. 3, where f prime of x is negative, it is decreasing, and when where f prime of x is positive, then the function is increasing. Note, the first derivative test. If x equals c is a critical point of the function f of x, then if the sign of f prime of x change from positive to negative, then f has a local maximum at x equals c. If the sign of f prime of x change from negative to positive, then f has a local minimum point at x equals c. Note, if f of x equal negative absolute value x minus c, then x equals c is local maximum. But if f of x equal absolute value x minus c without negative, then x equals c is local minimum for the function f of x. Exercises of lesson 4.1. Question number 1 to 3, find the value of the derivative at the indicated local extremum. Question number 1, f of x equal x power 2 over x power 2 plus 4. The indicated point here, it's the origin point 0, 0. F prime of x at this point is 0, since the function has a horizontal tangent line at this point, and the function changed from decreasing to increasing, therefore 0, 0 is a local minimum point. Question number 2, f of x equal cosine pi x over 4. This is the graph of this function. There is 2 indicated points at this point and this point. As you see, the function has a horizontal tangent line at these 2 points. Therefore, f prime of x at these 2 points is 0, since the function changed from increasing to decreasing. Therefore, the graph of its derivative intersect with the x-axis at this point at 0. and the function changed from decreasing to increasing at this point. Therefore, the function of the derivative, the graph of the derivative of this function intersect with x-axis at this point. Question number 3, f of x equal 2 minus absolute value x, the graph of the function. The indicated point is 0, 2. The function, the graph, the derivative of the function at this point is not exist since the function has a sharp vertex at this point. Therefore, f prime of x equal to does not exist, and 0, 2 is a critical point, and 0, 2 is a local maximum point. Question number 4 to 10, find the interval on which the function is increasing and those on which it is decreasing. Question number 4, f of x equal x power 2 minus 6x plus 8. This is the graph of this function. As you see, the function is decreasing from negative infinity to 3, open interval. This is the interval of decreasing, and the function is increasing from 3 to positive infinity. 3 to positive infinity is the interval of increasing. Question number 5, f of x equal x power 3 over 4 minus 3x. This is the graph of this function. It is given. The function is increasing from negative infinity to negative 2. So negative infinity to negative 2, is increasing, and from 2 to positive infinity also the function is increasing. Therefore, the interval of increasing is negative infinity to negative 2 union 2 to positive infinity. This is the interval of increasing. The interval of decreasing is from negative 2 to 2, as you see. From this point to this point, the function is decreasing. Therefore, negative 2 to 2, open interval of decreasing. Question number 6, f of x equal cosine x over 2. The graph of this function is given here from 0 to 2 pi. The function is decreasing. Question number 7, find the interval of increasing and decreasing for this function. First, we find the critical point, f of x, rewrite it as x to the negative 2, then differentiate this function, f prime of x equal to negative 2, x to the negative 3 equal to negative 2 over x power 3. Set it equal 0 and solve to find x. Negative 2 equals 0, contradiction. There is no value of x from this equation. The derivative of this function is undefined at 0, but 0 is not in the domain of the function, so 0 is not, x equals 0 is not a critical point, and to find the interval of increasing and decreasing, set 0, f prime of x, find the sign of the derivative of function before 0 when x is negative, negative over negative, positive. When x is positive, negative over positive, negative, and therefore from negative infinity to 0 is the interval of increasing, and from 0 to positive infinity is the interval of decreasing. Question number 8, f of x equal x power 2 over x plus 1. Find the derivative of this function to find the critical point. The denominator, x plus 1, times the derivative of the numerator, 2x, minus the numerator times the derivative of the denominator 1 over denominator square, equal to, simplify this function, 2x times x, 2x power 2, 2x times 1, 2x minus x power 2 over x plus 1 square, equal to 2x power 2 minus x power 2, x power 2 plus 2x over x plus 1 square. Set it equal 0 to find the value of x, cross multiplication, then x power 2 plus 2x equals 0, factorize by x plus 2 equals 0, either x equals 0 or x equal negative 2. And the derivative of this function is undefined at negative 1, but negative 1 not in the domain of this function. So x equal negative 1 is not a critical point. To find the interval of increasing and decreasing, set x, f prime of x, and f in the table. This is the value of critical point, 0, negative 2, this is negative 1, and find the value of the derivative at between this critical point. When x greater than 0, 1 plus 2, 3 over positive value, it is positive. Between negative 1 and 0, negative half, square, quarter, minus 1, it is negative value, over positive negative value. Between negative 1 and negative 2, negative 3 over 2, square, 9 over 4, minus 3, it is negative value, negative over positive negative. When x less than negative 2, negative 3, negative 3 square, 9, 9 minus 6, positive value over positive value is positive value. Therefore, this interval, the function increasing, here the function decreasing, and from 0 to positive infinity, the function increasing. The value, the interval of increasing are negative infinity to negative 2, open interval, union 0 to positive infinity, and from negative 2 to negative 1, open interval, union negative 1 to 0 are the interval of decreasing, here the interval of increasing. Question number 9, f of x equal 27x minus x power 3. Find the derivative of this function, f prime of x equal to 27 minus 3x power 2. Set it equal 0, factorize by 3, 9 minus x square equal 0, x equal negative positive 3. Negative positive 3 are the critical point of this function. Then make a table of critical point, the sign of derivative, and the interval of increasing and decreasing. Here it's negative 3 and 3. When x is 0, between negative 3 and 3, the derivative of function is positive, 27 minus 0, positive. When x is greater than 3, 4, the function is negative. 3 times 16 is greater than 27. When x is less than negative 3, negative 4, also the function is negative. Therefore, the function here is decreasing, here increasing, and here decreasing. And negative infinity to -3 union 3 to positive infinity. These two intervals are interval of decreasing. From -3 to 3, open interval is the interval of increasing. The point x equal -3 is minimum local point for this function, and x equal 3 is maximum local point of this function. Question number 10, f of x equal x minus 2 cosine x in the interval. Find the interval of increasing and decreasing in the interval, open interval 0 to 2 pi. F prime of x equal to 1 plus 2 sine x, the derivative of -2 cosine x. Set it equals 0 and set 2 sine x equal -1 and sine x equal to -1 over 2. So the sign is negative in the quarter 3 and 4. Here the sign is negative. And x equal sine inverse a half equal to pi over 6. From the calculator, x equal sine inverse a half pi over 6. In the quarter 3, then x equal pi plus pi over 6 equal to 6 pi plus pi, 7 pi over 6. In quarter 4, x equal 2 pi minus pi over 6 equal to 6 times 2 pi, 12 pi minus pi over 6 equal to 11 pi over 6. This is the two critical point in the interval 0 to 2 pi. Now, to find the value or the interval of increasing and decreasing, set x, f prime of x, and f. This is the value of 7 pi over 6, and this is the value of 11 pi over 6. You can find easily that the value before 7 pi over 6, the derivative of the function is positive. Between 7 pi over 6 and 11 pi over 6, the value of the derivative is negative, and in the interval 11 pi over 6 to positive infinity, the value of the derivative is positive. Therefore, the function is increasing in this interval, decreasing in this interval, increasing here. And from 0 to 7 pi over 6, open interval, union 11 pi over 6 to 2 pi. This is the interval of increasing to this function. The interval from 7 pi to 6 to 11 pi over 6 is the interval of decreasing for this function. Question number 11, f of x equal x power 2x minus 3. Open this bracket, f of x equal to x power 3 minus 3x power 2. Find the derivative of this function, f prime of x, 3x power 2 minus 6x, set it equals 0. Factorize by 3x, x minus 2 equals 0. Either x equals 0 or x equals 2. This is, or these are the critical points. Set it in the number line 0, 2, f prime, and f. The sign of the derivative for the value less than 0, negative 1, 3 times 1, 3, minus 6 times negative 1, positive. Therefore, the sign of derivative here is positive. Between 0 and 2, take 1. 3 times 1, 3, minus 6, minus 3. Then the value is negative. When x greater than 2, take 3. 3 times 9, 27, minus 18, positive value. Therefore, this is the interval of increasing, and here is the interval of decreasing. From negative infinity to 0, union 2 to infinity, these two intervals are interval of increasing, and from 0 to 2, open interval is the interval of decreasing for this function. The needed of the questions 11 to 13 is only find the critical point. Here the critical point is 0 and 2, the interval, and also you find the interval of increasing and decreasing. Question number 12, open this bracket, f of x equal to x power 4 minus 4x power 2. Find the derivative of this function. 4x power 3 minus 8x equal 0. Factorize by 4x, x power 2 minus 2 equals 0. Either x equals 0 or x equal negative positive square root 2. These are the critical point of this function. You can open this bracket, difference of 2 square, x minus square root 2 times x plus square root 2, then x equal negative positive square root 2. Question number 13, f of x equal x minus 1 over x minus 2. Find the derivative of this function. Apply the rule of division of two function. The denominator times the derivative of numerator 1 minus the numerator x minus 1 times the derivative of the denominator 1 over denominator squared equal to, simplify, x plus 1 minus x plus 1 over x plus 2 plus 1 power 2. X with negative x equal to 2 over x plus 1 power 2. Set it equal 0. Then we get an introduction to equal 0. Contradiction. Then the derivative is undefined at negative 1, but negative 1 is not in the domain of this function. Therefore, the function has no critical point or value. Question number 14 to 22, find the critical values, interval and of increasing and decreasing, identify the local maximum and minimum extremum. Question number 14, f of x equal x power 2 minus 6x. Find the derivative of this function, f of prime of x equal to 2x minus 6. Set it equals 0. Factorize by 2, x minus 3 equals 0. Then x equal 3 is the only critical point of this function. Now find the interval of increasing and decreasing. Set 3 in the number line and find the sign of the derivative of this function before 3 and after 3. Before 3, take 0. Find the derivative as 0 is negative. 0 minus 6, negative. Take 4, 2 times 4, 8 minus 6, 2. Then the interval of decreasing is from negative infinity to 3 is the interval of decreasing, and from 3 to positive infinity is the interval of increasing. Find f of 3. Substitute 3 in the function. 3 power 2, 9, minus 6 times 3, 18, equal to negative 9. Then 3 negative 9 is local minimum point for this function. Question number 15. Find the derivative of this function f of prime of x equal to 3 times 2, 6x power 2 plus 6x minus 12. Set it equals 0. Divide by 6. X power 2 plus x minus 2 equals 0. Factorize or analyze by experiment. X negative or positive 2 negative 1 equals 0. Then either x equal negative 2 or x equal 1. Set these two critical points in the number line, negative 2, 1. Find the value, the sign of the derivative before and after and between these values. When x is less than negative 2, take negative 3, negative 3 power 2, 9, it is positive. Therefore, here the sign of the derivative is positive. Between negative 2 and 1, take 0, 0, plus 0, 0 minus 2, negative 2. When x greater than 1, take 2, 2 power 2, 4, plus 2, 6 minus 2, it is positive. Therefore, here the function is increasing, this interval decreasing, and here is increasing. Then the interval of increasing are negative infinity to negative 2, open interval, union 1 to positive infinity. This is the interval of increasing. The interval of decreasing is from negative 2 to 1 is the interval of decreasing. Now, the point negative 2, substitute negative 2 in the function to find the value of y coordinate. 2 times negative 2 power 3 plus 3 times negative 2 power 2 minus 12 times negative 2. Negative 8 times 2, negative 16. 3 times 4, 12, plus 24. It is negative 4 plus 20. So negative 220 is a maximum extremum point for this point, and when x equal 1, 2 plus 3, 5, 5 minus 7, minus 12, negative 7 is minimum local point for this function. Question number 16, f of x equal x power 2 times 3 minus x. Open this bracket, f of x equal to 3x power 2 minus x power 3. Find the derivative of this function, f prime of x equals 6x minus 3x power 2. Set it equals 0 and find the value of x, factorized by 3x. 2 minus x equal 0. Either 3x equals 0, then x equals 0, or 2 minus x equals 0, then x equals 2. This is the critical point of this function. Find the sign of the derivative at this point, 0 and 2. Then find the interval of increasing and decreasing. Before 0, -1, the derivative is -6 minus 3, -9. Between 0 and 2, 6 minus 3 is positive. When x greater than 3 or than 2, 3, 6 times 3, 18 minus 27, it is negative. Therefore, here the function decreasing, between 0 and 2 increasing, 2 to positive infinity, the function is increasing. Therefore, negative infinity to 0, union 2 to positive infinity, these two intervals are the interval of decreasing for this function, and from 0 to 2 is the interval of increasing. The local extremum point are 0, substitute 0 on the function, 0, 0 is local minimum point for this, and 2 by 2 power 2, 4 times 1, 4, 2 by 4 is maximum local extremum for this function. Question number 17. Find the derivative of this function to find the critical point. The denominator times the derivative of the numerator, 5 times 5x power 4 minus 5 minus the numerator derivative of the denominator 0, 0 over 25 equal to, simplify this derivative, factorize also by 5, 25 x power 4 minus 1 over 25 equals 0. Then x power 4 minus 1 equals 0. Open difference of 2 square, x power 2 minus 1, x power 2 plus 1 equals 0. Also open difference of 2 square for this bracket, x minus 1, x plus 1, x power 2 plus 1 equals 0. Either x equal 1 or x equal -1. From this bracket, x equal to square root -1 is not real number. Therefore, the only critical point are -1 and 1. Find the sign of the derivative at before and between this point. When x equal -2, the derivative is -2 power 4, 16 minus 1, positive over positive. The value, the sign here is positive. Between -1 and 1, 0 minus 1, -1 over 25, negative. And when x greater than 1, it is positive over positive, positive value. Here the function is increasing, in this interval decreasing, and from 1 to positive infinity the function is increasing. Therefore, from -infinity to -1, union from 1 to positive infinity, this two interval is the interval of increasing, and from -1 to +1 is the interval of decreasing for this function. And when x equals -1, the y coordinate is -1 power 5, -1 plus 5, 4 over 5. It is a local maximum point since the function changed from increasing to decreasing. And when x equal 1, the function is 1 minus 5 minus 4 over 5. The value here is minimum since the function, the sign change from decreasing to increasing. See you next lesson.